Hello everyone, and welcome to my senior project presentation for the summer of 2015. I'm going to be talking to you today about safe work permits. Basically going to be explaining each section that needs to be on it, why that section is there, rules, regulations, general guidelines, and statistics, injury and illness statistics related to those sections. It's going to be a pretty broad view. But let's dive in. So what is a safe work permit and what is it used for? Basically, it's a piece of paper that's going to have a list of jobs, and it's going to have their hazards associated with those jobs, mitigation techniques. Some sections are required by OSHA for record-keeping purposes, but basically they allow the worker to work in a hazardous environment. They do not mean that safe work is going to be performed, however. These are some examples of safe work permits that are being used in the industry today. This is Permit A, and as you can see, it's pretty comprehensive, has a front and a back to it, which we will get into. I know you can't read it right now, but I have the sections cut off and blown up, so you'll see those later in the permit. Here is permits B and C. As you can see, they're not as comprehensive, but that is because some of their sections come with their own permit, such as confined space and stuff like that, but we'll get into that. So here we go. The first section is permit type and scope. So basically you're going to have the permit issuer and requester on here. The issuer is normally going to be the operator, and the requester is going to be the employee that's wanting to do the work. Normally you're going to have their name on there, their employee ID, and their company as well if they are a contractor. Area and unit of description, basically where the work is going to be done, and then the date and the time, the duration of validity, which is the time window that the permit is good for. It can be 8, 10, 12 hours if it starts at the beginning of the shift. As you can see here, there is the date, the time, company, person requesting permit. Basically, all three of my examples follow the same general way that they go about doing that. Hazards and PPE are going to be your next section. Basically, the company needs to make sure that they implement engineering controls first, which are going to be the elimination. The fundamental theory of engineering controls is that they should eliminate and or reduce exposure to hazards to the furthest possible extent, and that can include designing them in a way that does that, or removal of equipment. The next step is administrative controls, and that's OSHA says it's a rotation of workers, breaks, stuff like that, but many consider safe work practice as administrative controls, and those need to be tailored to the company's specific hazards depending on their industry. And then finally, once you do that, you get into PPE. Here are my three examples of the permits and their PPE. Basically, OSHA 1910 subpart I is going to be your guidelines on this, and it's going to give mandatory PPE for the oil and gas industry. At least the mandatory PPE is going to be hard hats, eye protection, safety-toed boots, fire retardant clothing like what I'm wearing right now, and a 4-gas monitor. But there's also special PPE, which you can see on here, which is going to consist of basically things like specialized gloves, hearing protection, respirators, chemical suits, face shields, etc. A lot of those are on there. I'm not going to list all of those, but basically the company needs to provide any of these at no cost to the employee, but it is important to know that PPE is only a last line of defense. So we'll go into fall protection pretty briefly. The Department of Labor statistics found that 724 out of the 4,548 workplace fatalities in 2013 were a result of slips, trips, and falls. So it is a big deal. And then 1926 subpart M is going to be your guidelines on that. Basically, what's not listed on here is the inspection of AWPs or aerial work platforms. Other than that, you've got to have a list of restraint devices, which need to be inspected by the permit issuer as well before work begins. And now we got hazardous energy control. I could make my entire presentation about this, so I'm going to make it as brief as possible. So it's commonly referred to as lockout tagout. In 2013, OSHA found that proper procedures could save 121 lives and prevent 50,000 injuries per year with proper procedures. Their standard on this is going to be 1910 147, the control of hazardous energy. It requires a lockout tagout program, which is basically listed right here. You got everything you need on that program, as well as the next slide, which has the various forms of hazardous energy: electrical, chemical, mechanical, gravitational, pneumatic, pressurized, liquid or gas, all hazardous forms of energy. And 147 is going to require everything that you see here as well. So next we got hot work. So it's not just welding, it can include flame cutting, riveting, any other spark producing job. 1910-252 isn't listed on here, but that's the OSHA standard for that. And it's going to give requirements for hot work in general industry. Basically, the first step before hot work is the removal of the material that you're going to be doing the hot work on. When that is impractical, then you need to move any combustible material out of the area to a safe distance, normally 35 feet. If that's not practical, then you need to shield that combustible material. Also required is a fire watch, who needs to be trained to extinguish any fires that occur, and they need to be present for 30 minutes after the work has been completed. And then finally, atmospheric monitoring, but we're going to get into that here pretty shortly. So next is confined space. There are 11,000 non-fatal and 92 fatal injuries per year. That's a pretty interesting statistic because there's 4.8 million injuries per year. Might lead you to believe it's not that dangerous, but it really is. So a lot of times there's confusion on permit required versus non-permit required. So for a confined space in general, it needs to have all three of these criteria: large enough to bodily enter, limited means of entry and exit, and not designed for continuous occupancy. Once it has all of those three criteria, then you can determine whether it's permit required or non-permit required. To be permit required, you only have to have one of the following criteria: potential for hazardous atmosphere, potential for engulfment, or potential for entrapment. And then 1910.147 is going to be your confined space program, and it's going to cover the responsibilities of the entrant, attendant, and supervisor, as well as what you see right here. But that's the next page. So you got your attendant, the time that each attendant's name, the time that they're attending. Same for the supervisor, and also the authorized entrants, when they're in, when they're out. All of this is required by OSHA's confined space program. Next, we have atmospheric monitoring. So mainly I'm going to be talking to you about 4-gas monitors, although there are other methods to test the atmosphere. So basically, LEL, or the lower explosive limit, is the lowest concentration in the air that gas needs to ignite. Basically, the alarm should go off at 10% of the LEL. Some people might find this confusing. but the 4-gas monitor needs to be calibrated to a specific gas. Normally it's methane. That way the LEL shows the correct value on there. The next is oxygen, and we all know that that needs to be 19.5% to 20, anything underneath 23.5%. So deficient, oxygen deficient to oxygen enriched there. Next is H2S, or hydrogen sulfide. It's basically found in oil and gas industries. Permissible exposure limit on that is 10 ppm. And then next is CO, or carbon monoxide, which is produced by anything that burns fuel, and it has a permissible exposure limit of 35 ppm, and that's when your alarm should be going off on that. Here are the examples I have. You can see that they all basically consist of the same stuff. Allow the user to test multiple times, and on permit A and B here, basically it's just going to allow you to put the last calibration date on there. This is a brief slide. Additional safety precautions. They're necessary for any job contained within any job that's not necessarily contained within the permit, but that the facility or the company deems necessary to be permitted. It could also be supplementary information of hazards if they're not included in any of the previous sections that I've listed. Then the final step is communication and authorization. And obviously, communication, authorization, final step prior to work, continuation, and termination. These are the 3 examples of that. Basically, communication is going to be between the permit issuer and the person requesting the permit. Basically, has work been completed or not? And then authorization is going to consist of a signature of the issuer that means that all of the sections on the permit have been complied with, training has been completed if needed, hazards have been eliminated or mitigated as necessary. Continuation, that would mean extending the duration of validity, like I said earlier. And then finally termination, which the job has been completed and the permit is going to be stored for record keeping. So basically, that is a very broad view of a safe work permit. So I just wanted to list a couple key points. The first of which is that it is encouraged that companies' policy exceeds the OSHA regulations that govern these sections. Those regulations are only minimum standards. Next is training, very important. It needs to be given to all those who have not received it by the company issuing the permit. Mostly contractors, but it can also be employees who are new to the location, or anyone that is seen as lacking in knowledge required to complete the job in a safe manner. Thank you for watching, stay safe, and have a great day. Thank you.